Hi, I'm Alan Ross. This is an APC Media IEEE interview. We didn't get to do this with Nick Lukenda at IEEE. He walked up just as the cameras were being packed up. Sorry about that, Nick. We tried, but this is the last one that we're able to do and still publish as an IEEE APC Media. It really came at the PES T&D, and that is a lot of acronyms, isn't it? Event in New Orleans. So good to see you again, Nick.
Yeah, nice to see you as well. Thank you very much for accommodating me.
So Nick is the technical director. Is that the title?
I'm the senior services, our technical services advisor.
Senior? Okay, I'm not even going to try to do that. To me, you're the king of technology for the lubricant, Petro-Canada Lubricants, which is a division of, was a division of Sinclair, which is now a division of a much larger company that's doing all this stuff. But the thing that we're interested in is the transformer oils, the fluids. Let's just do it at that. But before we get to that specifically, the question that I ask everybody is, what is happening in the world? Now, you can focus on the world in general. And I know you're from, your family was from Croatia, so what's going on in Ukraine must be an issue for all of you. But really, in the world of transformers, transformer technology, oils and fluids, what do you see is going on?
All right, first things first, let me make a pot of coffee because there's a lot going on in the world. But specifically within the transformer oil world, you know, everything is interconnected. Everything is so interconnected. And the first thing that pops up is supply chains and the importance of delivering product, because the industry that we support is not just something that can sit idle. You know, electricity in the transmission and distribution and the generation is critical to every aspect of life. And we all play a role in that. And that's in the production and the supply of the insulating liquids and oils, the transformers themselves, the testing and the monitoring. So there's definitely some increased, you know, not severity or pressures, but awareness of we need to keep things, we need to stay on top of the ball despite all the supply chain like issues that might be happening in the world. And we've been very good with that. And that's something that we pride ourselves on. That's something that we try to be mindful of. Because again, this is not just something where an industry where you can just kind of sit idle. On the technology side, this is where I'm most interested as to like what's going on with fluids and the world in that sense. I think it's fair to say that the transformer industry at times can be a little bit slow moving.
No. And we say snail's pace, but you're exactly right. Yeah.
Yeah, and it can be a little bit frustrating at times, but I understand why we need to be conservative. Because again, the criticality of the infrastructure that we support does not make it very viable to someone just saying, "Hey, I have an idea. Let's throw in, you know, 30,000 liters or 20,000 gallons of this new fluid in the transformer, and let's see what happens." It doesn't quite work that way.
Let's do a lifelong study to see if this really works. But let's go ahead and put it in 100,000 transformer. I know, I agree with you. Yeah,
absolutely. So I think that's one of the biggest challenges facing our industry. And for me personally, I think about, it comes down to like 3 S's. It's severity, sustainability, and savings. Those are the questions that I get from my customers the most often. And severity is just tied into what kind of trends we're seeing on a global scale. And this applies everywhere, be it in Europe, North America. We're seeing increased demand and stresses on transformers. This comes through increased electric vehicles, the fluctuations which happen onto the grid through increased renewables, increased solar, the intermittent energy that's provided. All of these create stresses. Now, we need to be able to manage the severity of these units. And that really comes down to managing the heat dissipation, which is a function of the fluid and the transformer oil in that case. And that's what I'm particularly interested in. And we want to do it in a sustainable way. And we want to be able to monitor some metrics to make sure that it is sustainable and that it provides savings to our customer. And you hit the nail on the head where the most difficult part to all of that is that these aren't, 1-week field trials. Transformers are out in the field in various ambient conditions, various stresses that change depending on, if we have record heats in one summer and you have increased air conditioner usage, the loading on that transformer is going to be totally different from what is being used in another transformer, similar kV rating, say, or even that same transformer year to year. So how do we quantify those results? How do we actually show that what changes we propose to the liquid provide tangible performance benefits and savings to the end user?
When you say changes to the liquid, so you're talking primarily about how the refining process takes it from oil into transform oil. You talk about additives and the things that are that you put into it to do that. That's a challenge that you've got. You also have the challenge of people saying, well, you know, we like soybean oil in our transformer, and it's got certain, so you've got a competitive market as well. But, you know, the old standby, and I think it's what 88 to 90% of the market is what you produce. You know, it's a mineral oil, and it has been there for a long time. So what are the kinds of changes? What are you trying to accomplish by bringing these changes you're talking about to the technology of the oil?
Yep, absolutely. So first things first, you know, form defines function. And in our case, we talk about the chemistry of the oil. Because oils are 90% of the market, and because they are so entrenched in the history of the market,
Yeah.
users tend to get a little bit comfortable with oils. And oil is an oil. And that speaks to a certain extent of the benefits of the standards that we've implemented. ASTM D3487, the IEC standards, the IEEE standards. Canada has its own standards, CSA C50 as well. But those standards just establish benchmark performance. This is what the oil needs to do to be safe and to get the job done. But beyond that, based on how you run your refinery, based on the crude oil that you source, there are some differences. So our product itself, luminol, is based on a paraffinic mineral, which we refine and we convert to a highly isoparaffinic oil. The majority of oils used in the market are naphthenic based, and those are the two types of crude widely available in the world, naphthenic and paraffinic. And that comes down to the chemistry which is present, which has some different performance benefits. Most importantly is one difference is density, where we see isoparaffinic oils have about 7% lower density than naphthenic oils. So that helps with mobile substations or with the pad requirements of a transformer. But what we've discovered is also some heat transfer differences that happens based on the chemistry which is present. And you could also change the viscosity of the oil. You can change its heat transfer properties, which is really the most important function of an oil. Now, we can't deviate outside of the accepted standards because that is established and that's accepted, but we can start to tweak some of those parameters, viscosity, density, hydrocarbon composition, and then see how that improves the performance. But we need to be able to convey the value to the end users and really have them be curious to try it.
You mentioned mobile subs, and we've got an article coming in. There's a couple of companies that we know pretty well. Delta Star produces great mobile subs, and they've developed one for cities that are rapid, you know, they are rapid deployment type things. I know there's one coming out of Europe that we're not allowed to talk about, but we will be part of the launch of what they're attempting to do with their mobile subs. I had the assumption that because it was a mobile sub, they would always want the plant-based oils. What I found out is because that transformer is going to be asked to do a lot more, you know, because they don't know where it's going to go. It's not like a mobile sub going here. It's going to be a lot more. That my assumption was wrong, that they're going to have oils that meet a lot of different criteria. Is that what you're talking about? Making sure whatever you're producing, you got to look at the end use, which you don't even know yet. It might be in New York City one week, and it could be in Houston, Texas. Maybe they won't do that. Hopefully we deploy enough of them around our United States and Canada and Europe that we're within, I think Department of Energy would like us to be within 100 miles. No, excuse me, I take that back. Within 200 miles, you're able to have a mobile sub that can be deployed. If you take that and you look at North America, that's a lot of mobile subs that are going to be required in a lot of different instances. In Canada and the northern parts of the United States, you're dealing with more cold. So that's where viscosity comes in, I assume. In the southern part, you're dealing with heat. In California, you're dealing with fire. I mean, the environment is different. So how do you adjust the chemistry to meet the different demands of the environment, or do you?
Yeah, well, Oddly enough, they're kind of related in that sense. So if you
Okay.
have an oil which can be highly refined, you remove the impurities, and most importantly, want to manage the wax content.
Okay.
And if you have a fluid or an oil which has good heat transfer capabilities, at that point, because it's so highly refined, it'll dissipate heat better in those high temperature environments. But because you manage the wax and you refined it so well, it's not going to have a high viscosity at cold temperatures. So you're able to move that substation around and bring it over to different climates. And again, be able to accept different loadings and severities based on where it is. But you're right. It's important to have a resilient unit. Everyone's being asked, do more with less. Now we need to
Yeah.
have backup infrastructure. You need to have a mobile substation that can very quickly adapt to whatever stresses are being placed on it. And ultimately, that means your oil has to be that much more resilient to handle those stresses.
Excellent. As an old transformer guy myself, the life of the system is the transformer, and the life of the transformer is the paper. And without oil, the paper is not going to last. So it's this this capability of the oil to do, and it's also a great diagnostic tool for what's going on inside the transformer. So the basics and all of that create more. It's funny that you would think, oh, there's no more research development in oils. Oils are oils. I see more work on oils today than at any time in my career because of all of these requirements. I love that. Severity. What was the other one? Severity,
sustainability, and then savings.
I love that. I thought you were going to say safety.
Yeah, well, safety
So
too.
make it 4 S's. Okay, add another S in there. Safety.
Yeah.
You're an IEEE, and you are an IEEE member. Tell me the value of an IEEE PES T&D, whether it's the T&D show or anything that kind of fits in your area. What's the value of IEEE to you and to your company?
Yeah. So you are talking about the nucleus of the industry. You know, this is where everything congregates. And from one booth to the next, you can easily get enthralled in a 1 hour conversation. Then you turn your back, then you have another hour-long conversation.
Yeah.
I wore the soles out of my shoes at this show. And I have to admit, this was my first time attending the T&D show.
Okay.
It is held only once every 2 years.
Yep.
And obviously some things have happened, so we weren't able to attend the past couple of years. But it was such a fulfilling opportunity to be able to connect with so many different partners, from utilities, from other manufacturers, from suppliers, from testing labs. These are all integrated partners, and we need to maintain that integration. And the T&D show is the best place to do it. The IEEE on a higher level too, being a working group member, is the technical resource. I mean, we established the guides that give the best recommendations, and whether it's C57-154 or C57-166, these are the 2 guides that I'm most involved with right now. But this is where we really do research the oils. So with 166 right now, just as an example, you know, we're looking at how do we truly evaluate the thermal operating limits of an oil? And this is done in partnership across our competitors, truly, because at the end of the day, we need to make sure that we're on the same page. The same test is being developed, the same metrics are being used to make sure that our end user, the most critical user, the utilities, the end users of all the transformers, are truly aware and the values are reflective of the real results.
IEEE and collaboration are like hand in glove, and it takes people like you who are willing to get on the working groups, who collaborate. And as you said, you know, side by side with competitors, you learn from each other. But it is it is the most collegial, and I mean that by people sharing, willing to share. And that also happens at these events. The events are situations where, as you say, you will gain a ton of information. People will take information from you, but it's a very collaborative rather than competitive environment. And I love that about IEEE and the working group. So this has been an APC Media. We were supposed to do this at IEEE. Our bad, we shut the cameras down. But here we are doing it again with Nick Lukenda. Nick, I would love, I think I've made this offer before, but I'm making it on camera. So if you say yes, I have you. I'd love for you to become a technical advisory board member on the oils and fluids side, because you have a wealth of knowledge. And like IEEE, we don't do working group things. We don't produce standards. But what we do is we take good information, and the technical advisory board member is required over the course of a year to produce 2 good pieces of purely editorial technical information that we can share with the APC media audience. But I'd love for you to become a technical advisory board member. We don't pay anything. We're like IEEE, but it'll be complementary to the work that you're already doing, and it will be side by side with some of the technical people from your industry. So your answer is?
Yeah, absolutely.
Okay,
let's
yes.
talk afterwards. Yes, yeah.
No. We don't talk afterwards. It's a done deal. No, we will talk afterwards. I'll talk about what we're trying to do in there. But I'd love what, as you were sharing, it kept going. Tab, what we call it, the tab. I think that's going to be beneficial. But again, thank you so much for joining us. I'd shake hands with you if I could, but I did that at the IEEE PES T&D New Orleans conference. We have another conference coming up, there's a lot of them, obviously, but in April next year in San Diego, the Grid Edge, PES Grid Edge Conference, which you could think of as grid modernization, decentralization, new technologies, all of those kind of things. So we're pretty excited about that. I get to be on the steering committee and listen to these brilliant people put the program together. We think it's going to be pretty exciting. We have lined up San Diego for 2023, 2025, 2027. So every other year, you said the PES T&D is 2 years. Every other year will be Grid Edge. So once a year, we're going to have an IEEE PES pretty major conference and exposition. I'd love to see you guys there. Yeah, we'd be happy to attend. Knowledge sharing is, how we move the industry forward. Okay, great. Thank you so much. This has been an APC Media IEEE presentation.